Hello everyone. In today's video lecture, we will discuss about module 3 concepts in microcontroller and embedded systems. In the previous video section, we seen about embedded devices, major applications, purpose, and also core of an embedded system. Different types cores of embedded system we seen in the previous video lecture. Today we are going to discuss about memory, sensor actuators, LED, 7 segment LED display, stepper motor, keyboard, push button, switch. We have to refer textbook Introduction to Embedded System by Shibu KV. We will start the concept by using this memory. What do you mean by memory? This is very important thing. Memory is important part in an embedded system. In embedded system you have to use this. Not only embedded system, everything. In general purpose computer also we have to use memory. In special purpose also we have to use memories. We have actually two types of memory. One is primary memory, another one is secondary memory. You know that, but primary memory means what? Primary memory means you can give example as RAM, ROM, that all are primary memories. Secondary memory means we can give one example as hard disk. Like that, we have another two parts here, on chip memory and off chip memory. That is also called internal memory and external memory. Internal memory means in embedded device. Embedded device means it is a combination of software and hardware that contain many of the small components. If that memory is there inside that kit or embedded device, that is called internal memory. Sometimes that internal memory is not enough to store program or data. At that time we have to attach some extra memory. That extra memory we are going to connect outside of that embedded device. That is called external memory. This is mainly in the case of embedded device. We have two types, on chip and off chip. Name itself, on chip means inside the chip itself, inside the embedded device or embedded system or kit. Inside that itself we have memory. But if that is not sufficient for our work, then we can attach another memory to that device outside. That is called off chip memory or external memory. Here we have normal difference, that is a primary memory and secondary memory. In that primary memory again we have two types, that is program storage memory, that is ROM and RAM. ROM full form is read only memory, RAM full form is random access memory. We are going to discuss about ROM and RAM in the next slides. Also we are going to discuss different types of ROM and different types of RAM. We will start with a program storage memory or ROM. What is meant by program storage memory? Definition is, it stores the program instructions. This will store program instructions. ROM means read only memory. You can read. Once it is write, then only you can read. After that you can't edit or you can't modify. That is ROM. Another definition we can tell it as, retain its content even after the power off. In the ROM concept, this will retain the data or content after switch off your device. So this whatever we are going to save your data in ROM means that we can call it as permanent data. Another name for this is non-volatile memory or non-volatile storage memory. Once data is stored in here, data or instruction, anything, once we are going to store anything here, that is we can call it as permanent itself. Okay, we can't edit also, that is permanent. And depending on some of the factors, we are going to divide this ROM or program storage memory into some of the types: flash, NVRAM, NVRAM is non-volatile RAM, then PROM, masked ROM, EPROM, EEPROM. We are going to see each one of these in detail. First one, we are going for masked ROM. Masked ROM, another name is MROM. It is one-time programmable memory. That means you can store once, means you can't change. One-time programmable, you can change it only one time. Initially nothing is there in that memory. You can store or you can write anything in that. Once you written anything, you can't erase that. That is permanent. Uses hardwired technology for storing the data. This is one technology we are using to store the data inside the MROM. Program or device that cannot be changed. One device we considered means there we are going to use masked ROM. Then we are going to write something in that memory. Once you return, device also you can't change. That means once in that device that program is written means you can't change that, you can't edit that program. The primary advantage of MROM is low cost for high volume production. Low cost for high volume production. If you are producing this MROM in big content, then cost is low. If you are producing that 1 or 2 MROMs, then sometimes this cost may be high. MROM is the least expensive type of solid state memory. We are going to study this solid state memory in coming classes. Here in order, this is one type, least expensive type of solid state memory. This is the least expensive, cheaper. The limitation with the MROM based firmware storage is the inability to modify the device firmware against firmware update. This is the disadvantage or limitation. What is that limitation? MROM based firmware storage. Firmware storage means we can call it as another name, software. If you are going for software storage, if you are using this MROM for software storage, this is actually you can't store, actually don't take this MROM. The limitation means don't take MROM for software storage purpose, because you can't modify that. Once your software is there inside MROM, after if there is any software updates, you can't modify or you can't update that software present in MROM. That is the limitation or disadvantage, because MROM once it is programmed, you can't edit that. So you can't make any software updates. The MROM is permanent in bit storage. It is not possible to alter the bit information. If you are going to store anything in terms of a binary value, bit, it is not possible to alter or modify the information. This is about masked ROM. Next, programmable read-only memory. Another name is PROM. Here, It is not pre-programmed by the manufacturer. It is not pre-programmed. That means programmable. You can change, you can modify, programmable. The end user is responsible for programming this device. That means any end user. If you are the end user, you can modify that, you can edit that code present in PROM. PROM has nichrome or polysilicon wires arranged in the matrix. These wires can be functionally viewed as fuses. We are going to use some nichrome or polysilicon wires in the rows and columns. We are going to set it as rows and different rows and columns, and we are going to store some bit information in that polysilicon wires. That means we are going to program. It is programmed by a PROM programmer, which selectively burns the fuses according to bit pattern to be stored. We are going to burn, we are going to store, or we are going to load. That is called burning. Burning the fuses. Fuses means lot of polysilicon wires arranged in rows and columns. Fuses which are not burned represent a logic 1, whereas fuses which are burned represent a logic 0. If you are not programmed anything, that means if there is memory is completely free, then your fuses represent number 1, that is logic 1. If you are burned that fuses or any of the fuses in memory you programmed means, then that logic bit becomes 0. 0 represent already programmed. 1 represent it is not programmed, it is free, it is ready to program. It is about PROM. Next we have erasable programmable read-only memory. The short form is EPROM. Erasable programmable. You can erase, you can program. This is another different types of ROM. Here you can program also. If you are programming, if there is any error in the program, you can erase also, and again you can reprogram. This EPROM memory gives the flexibility to reprogram the same chip. If there is any update it is there, or you are loading any software in EPROM and you are getting any software, new software, or if that current software update, then you can do that, you can update that software. That means the reprogram is possible. If you want to erase that program, then if you want to load another software, that is also possible in this case. That's why erasable. EPROM contains quartz crystal window for erasing the stored information. In this quartz crystal window, we are using one method. What is the method? If the window is exposed to ultraviolet rays for a fixed duration, the entire memory will be erased. Here erasable means we have to erase if there is any wrong information is there in ROM. That means if that you want to, that means user want to erase that some data in the ROM, that means EPROM, then you can do that by using quartz crystal window. What is the method we are using? We are exposing window to ultraviolet rays for particular amount of time, that is a fixed duration. Then entire memory will be erased. But this fixed duration is very important. Don't expose that EPROM more than that fixed duration, that will lead to some problem. This is about EPROM. Electrically erasable programmable read-only memory. Previous one only erasable programmable read-only memory. This one is electrically erasable programmable read-only memory, EEPROM. Here erasable you can erase, programmable you can program. In the previous case we used quartz crystal to erase your program. In this we are using electrically erasable. We are using some electrical method or electrical signal to erase your program. Electrically erasable memory gives flexibility to reprogram the same chip using electrical signal. The information contained in the EEPROM memory can be altered by using electrical signal at the register or byte level. They can be erased and reprogrammed within the circuit. You can erase that or reprogram by using electrical signal. That is the main point here. These chips include a chip erase mode, and in this mode they can erase in a few milliseconds. There is a one special mode in this electric EEPROM, that is a chip erase mode. If you are activating the chip erase mode, then we can erase that memory within a very few milliseconds. Otherwise, if that chip erase mode is not active, that may take a lot of time. If that chip erase mode is active, then it takes very less time to erase this EEPROM. It provides greater flexibility for system design. Flexibility is there because we can erase that by using electrical signal. If you are using chip erase mode, then we can erase that in very few milliseconds. That's why it is more flexible compared to previous. Then flash ROM. Flash is the latest ROM technology and is the most popular ROM technology used today embedded design. We are using till today also. It combines the reprogrammability of EEPROM and the high capacity of standard ROM. Flash memory is organized as a sector or pages. This is the advantage. Third point is there, right? This is the advantage. Flash memory is organized as a sectors or blocks or pages. We are dividing that entire flash memory into pages. 1 page. Flash memory stores information in an array of floating gate MOSFET transistor. We are using MOSFET transistor concept here to store informations. The erasing of memory can be done at sector level or page level without affecting the other sector or pages. Another advantage, if you are going to divide entire flash memory in sectors, blocks, pages, you can program only particular page or you can erase only that particular page. That is the thing we have in flash memory. Here this line represents same thing. Page level without affecting the other pages. We can erase particular page without affecting, without deleting or without erasing other pages. Each sector per page, each page should be erased before reprogramming. Don't overwrite, just erase that and rewrite the program. That is the concept. Next type, ROM is over. Next we have to go for another type, that is RAM. ROM is non-volatile. Once you program, you can't delete that. That is permanent. There we have different types also there, erasable, electrically erasable, like that. This is the another type, read write memory random access memory, that is a RAM. RAM, here it is also called data memory. RAM is called data memory. Here this is volatile. RAM is volatile. Why it is volatile? When the power is turned off, if you are going to switch off the device, when the power is turned off, all the content present in this memory are destroyed or deleted, erased. That is the thing we have in RAM. This is the volatile. Once you power off, everything is erased. So we are not concentrating to save anything in RAM. This is for temporary purpose we are using, because once you turn off, that entire thing in RAM is erased. So we are not concentrating to save very important thing in RAM, only we are using for temporary purpose. RAM we have three types: SRAM, DRAM and NVRAM. NV means non-volatile RAM, DRAM means dynamic RAM, SRAM means static RAM. We will go for that three types. Static RAM, SRAM. Static RAM stores data in the form of voltage. They are made up of flip-flops, and this is the fastest memory. These are the three things they given in the static RAM. It is a fast and made up of flip-flops. Another we can add this: cost is high because it is made up of flip-flops. So cost is high, but performance also high, speed also high. Only thing is cost high. Remaining everything is speed, efficiency, performance, throughput, but everything is high in the case of static RAM. Dynamic RAM. DRAM stores data in the form of charge. They are made up of MOS transistor gates. We can call it as capacitors. Capacitor also we are using to build dynamic RAM. The advantage is DRAM is it's high density and low cost. Cost is low. Cost compared to static RAM, cost is low in the dynamic RAM. That is the advantage. But disadvantage is there. Since the information is stored as a charge, it gets leaked off with the time, and prevent this, they need refreshing circuit. So thing is, here we are using capacitor also. Capacitor or another thing is MOS transistor gates. If you are using capacitor, you know that capacitor will charge and discharge, charge and discharge. So you are going to store in capacitor means it charges till peak. Once it reaches peak, then automatically it discharges. That's why discharge means again data loss. In order to avoid that data loss, we have to use one circuit. We have to refresh that. That's why we have to use an extra circuit, that is a refreshing circuit. That is a disadvantage. For refreshing circuit, we have to prepare one design, and we have to build that design, implement that design. Non-volatile RAM. Random access memory with battery backup. This is the RAM, temporary, but here one advantage is there, that is the battery backup is there. We are going to use one battery backup, but that battery is there in on chip itself. Memory, with that memory, related to that memory, we are connecting one battery for backup purpose, because anyway RAM is a temporary, right? So in order to increase that time, okay, that means time means we need more time to store, more time we need data inside the memory. That's why we are going to add one backup memory. It contains static RAM based memory and minute battery for providing supply to the memory in the absence of external power supply. If there is any external power supply suddenly off, then we are going to give some supply by using that battery. Memory and battery are together in the package, single package. Okay, next, difference. There is a difference between SRAM and DRAM. This is another important thing, difference between SRAM and DRAM. Here made up of 6 CMOS transistor, here made up of MOSFET and capacitors. Here another thing we can call it as, here made up of flip-flops, here this is made up of capacitors. Doesn't require refreshing circuit. You know, refreshing circuit required for capacitor itself. That's it. So we are going for DRAM. Okay, they requires a refreshing circuit in the DRAM purpose. And SRAM low capacity, DRAM high capacity. Okay, then SRAM expensive because we are using flip-flops. That's why it is expensive. But here less expensive. Compared to SRAM, it is less expensive. And speed is high. SRAM speed is high, but DRAM speed is low. Only one advantage is the cost. Cost is low compared to SRAM. Only that is the advantage in DRAM. Then we have one concept called memory shadow. Memory shadowing means what? Here, shadowing of memory is a technique adopted to solve the execution speed problem in processor based system. Here one problem is there, you've seen the previously some of the slides we seen RAM and ROM. What do you mean by RAM? Random access memory. What do you mean by ROM? Read only memory. Read only memory, everything is permanent. Random access memory, everything is temporary. But speed is high in the RAM, speed is less, or accessing speed is less for ROM. So in order to access anything from the ROM, it takes a lot of time. In order to access anything from RAM, it takes very less time compared to ROM. So we are doing some modifications here. We need, in order to switch on your device, we need some of the basic codes for your input output devices. That all codes are there in ROM itself. In the ROM, we are making separate part that is called BIOS, basic input output system. There we have set of codes related to your hardware. When you switch on your device, first that code is run, then only your operating system will run. But if you are placing that basic input output system code in RAM, that will erase once you switch off your device. So we are keeping that all codes in your ROM, that is separate part, BIOS, basic input output system in the ROM. And whatever we are doing here is, we are taking that basic input output system codes to RAM after switch on your device. Once you are switch on your device, we are taking that code into RAM, execute that, after that again keep that back in ROM itself. That is a method we are using here. That is explained in the memory shadowing concept. In the computer system and video system, there will be a configuration holding ROM called basic input output configuration ROM, or simply BIOS. Now the manufacturer includes a RAM behind the logical layer of the BIOS at its same address as a shadow to the BIOS. And the first step that happened during the boot up is copying the BIOS to the shadowed RAM. We are copying the BIOS content to RAM and protecting the RAM, then disable the BIOS reading. No need to access the ROM directly, it takes a lot of time. So we are taking that BIOS data inside RAM, execute that. By that execution is faster because that is in RAM, right? RAM execution is somewhat speed compared to ROM. Then once it is over, then we can keep that back in ROM itself. This is concept explained in the memory shadowing. In order to select memory, which are the memory we have to select for embedded system, that decision we can make by using these factors. Memory selection for embedded system, these are the factors for memory selection. What are the factors? First one, speed. Speed should be high, memory speed should be high. Select memory speed, high memory speed. Okay. Next, data storage. What you are going to consider if you are going to select memory? Data storage should be high, right? Data storage size and capacity we are going to check in order to take that memory. Bus width also we have to concentrate, and power consumption, how much power it consumes, that also we have to concentrate. This is a very important factor, power consumption, also cost and speed. Okay, these are the three important factors. Cost, last one is a cost, that is a price. So what is how much amount we have to pay for that particular memory, that also matters. So these are the factors to select memory for particular embedded system. Another next concept is sensors and actuators. About this we seen in the first part of the video. You can see that first part of the video. We discussed about this sensors and actuators in that. Embedded system is constant interaction with the real world. Sensors and actuators are the devices that will use it to interact with the real world. That is a matter. Controlling or monitoring function executed by the embedded system is achieved in accordance with the changes happening in the real world. That means if you are going to use sensors, that will sense your some of the elements from the real world, take inside the embedded system, do some processing, and after that processing it gives some factor. That factor again you have to give it to real world. That is happening by using actuators. Sensors is a input device. Actuator we can consider as output device. Here we have the definition. Sensor, a transducer device which converts energy from one form to another for any measurement or control purpose. It is an input device. You are sensing some of the factor from real world. You are capturing that element or some images or some signals from the real world and giving to embedded system. That is the job of the sensor. You know many of the sensor types. So we are using many of the devices, many of the car, bike, and some of the embedded device also. You know that we are using sensors. Then we have actuators, a form of transducer device which converts signal to corresponding physical action. Here sensor will take that signal from the external world into embedded device. Inside embedded device there is some process. After that process again actuator will send that signal from your embedded device to external world. That's why this is output device. It will convert some signal to physical action or motion. Okay, so it is given to real world. It is output device. Input output. Why we are using input output? Sensor and actuator we can consider as input and output devices. Why we are using input output? The input output subsystem of a embedded system facilitate the interaction of the embedded system with the external world. We are going to interact our embedded system with the real world. We have device, that device want to communicate with the real world. At that time it should take some data from the real world, process and give some data to real world. That taking and giving policy, that is happening by using input output. What are the different input output we are using in this embedded system? That we are going to see one by one. First device we are using, that is light emitting diode, LEDs. About LEDs we already seen in the previous semester in detail. We discussed with some video lecture, also some of the animations. Light emitting diode is an output device for visual indication in an embedded system. That you know why we are using LED, for visual indication. This is again, is that input device or output device? Actually this is output device. Typical example for indicating the presence of power condition like device. If you are going to consider one inverter, if you have inverter in your home, there we have some of the LEDs, right? Device on. If you are going to on that device, you are getting that LED blink, device on LED. Battery low LED, that will blink if that battery is low. Charging, if that battery is charging, then charging of the battery, that LED will blink. For this purpose we are using LED. For battery operated handheld embedded device, like some of the device we are using LED for some purpose. LED is any LED is a PN junction. We seen that detailed diagram also in previous semester about LED. PN junction we are using the positive and negative. electron and hole, there is some reaction will happen, and forward junction, backward junction, reverse battery we have to go for. Some of here photodiode also we seen in the previous semester, photodiode and LED concept. Here reverse manner, forward manner, how we are going to apply battery, by that how you are going to change your PN junction reaction, then how we will get LED light, that thing we seen in the previous. So here PN junction is used, that is a diode, and contains anode and cathode. You know PN junction contain anode side and cathode side, and I think you know this, which one is positive and which one negative also, right? Yes. A resistor is used in series between the power supply and the resistor to limit the current through the LED. We are using resistors to control LED. If there is any lot of power given to LED, there may be a chance of loss of LED. That's why we have to protect that. For that purpose we are using to limit that current. To limit the current through LED, we are using one device, that is a resistor. This concept is related to LED. We are using that as output device. This is a input output device, one of the input output device of the embedded system. Second device is 7-segment LED display. This is also input output device, but can you tell me what is this? Is that input device or output device? We will see that. The 7-segment LED display is an output device for displaying alphanumerical character. We are using for displaying some characters. You know hexadecimal characters 0 to 9, then A, B, C, D, E, F. That characters we are going to display in this. Again, related to this, we seen one of the experiment in analog and digital electronics lab, displaying some counter numbers 0, 1, 2, 3 like that. Here we have characters. Name here 7 segment, they name itself, we have 7 segment. A is one segment, B here another segment, C, D, E, F, G till G, this 7 segment. Another segment is there actually here, that is dot, decimal point, DP, decimal point. The LED segment are named as A to G, and decimal point LED segment is named as DP. If you need this, you can switch on, otherwise you can switch off. If you want to display number 1, at that time either F and E is on or B and C is on, remaining all are off. If you want to display number 3, A is on, B is on, G is on, C is on, D is on, remaining all are off. Like this we are going to perform operation in 7-segment LED display. Here we have 2 types. 7-segment LED display are available 2 different configuration. One is common cathode and common anode. Here first diagram you can see here, that is common anode type. Second is common cathode. What do you mean by common anode? All the anode of the diode is connected together and giving to supply. Common cathode means all the cathodes are connected together and giving to some supply. Here another side, here anode we are going for connecting anode, cathode we are going to connect all cathodes. Another side is free, either it is connected to some of the limiting resistors also. Practically we are connecting this to limiting resistors. Then we have another device, that is an input output device, that is called stepper motor. This is not actually input device, that is an output device. Stepper motor is a electromechanical device. Electro means we are giving electrical signal, that is a mechanical device. Mechanical device will operate based on electrical signal. That is why electromechanical device which generates discrete displacement, that is a motion, in response to DC electrical signal. We are giving electrical signal in order to move your mechanical device. That is called stepper motor. But here another type is there actually DC motor. Here this is stepper motor, another type is the DC motor. Both DC motor and stepper motor we are going to study in our lab experiments. Practically we are going to study both movement of DC motor and movement of stepper motor. Then what is the DC motor? It differs from normal DC motor in its operation. DC motor produces continuous rotation on applying DC voltage, whereas a stepper motor produces discrete rotation in response to DC voltage. Here DC motor will rotate continuously. There is no stop, continuous rotation is there in DC motor. But in stepper motor there is a discrete rotation, small rotation. It rotates and stop, rotate and stop, rotate and stop. It will continue like that. But here there is no stop. Continuous rotation is there in DC motor. Stepper motor are widely used for industrial embedded application, consumer electronic product and robotic control system. These are the application of stepper motors. The paper feed mechanism of printer. In the printer also we are going to use stepper motor. Fax makes use of stepper motor for its functioning. Fax machine, you know that, and printer also. There we are going to use, this is the application of stepper motors. Stepper motor we have classified into two phases. One is unipolar, one is bipolar. What is the meaning of unipolar? A unipolar stepper motor contains two windings. We have two windings per phase. You know what do you mean by phase? Per phase we have two windings. The direction of rotation either clockwise or anti-clockwise, but direction of rotation of stepper motor is controlled by changing the direction of current flow. That stepper motor works based on electrical signal, that is the definition. How you are going to apply the current, depend on that your stepper motor will rotate. Bipolar, a bipolar stepper motor contains single winding per phase. One phase we have one winding, but in the unipolar one phase we have two windings. For reversing the motor rotation, the current flow through the windings is reversed dynamically. So, bipolar is somewhat complex compared to unipolar. Another embedded system input output device. Related to embedded system, we need an input output. Another input output device, that is push button switch. Push button switch is an input device. Input device, not output. I will give real time example for this later. Push button switch comes in two configurations, namely push to make and push to break. We can push to make also, we can push to break also, making and breaking. The switch is normally in the open state and it makes a circuit contact when it is pushed or pressed in the push to make configuration. We are making a circuit by pressing push to make. We are breaking the circuit by pushing break. Here we can consider your fan switch. If you are going to put a switch, then fan will rotate. That is called push to make. To rotate a fan, you are going to put switch. Push to make. To stop fan rotation, we are going to break that circuit. That is push to break. That is one of the example. That is a push button switch. Another input output device, we can call it as keyboard. Keyboard is an input device. It is also, you know that keyboard is an input device. We are giving input to the system by using keyboard. If the number of keys required is very limited, push button switches can be used and they can be directly interfaced with the port pin for reading. We can use push button switches to prepare keyboard also. Push button switches we seen in the previous slide, that also we can use to build keyboard. In the earlier days, we had only small 5 number of keys, 7 number of keys in the keyboard. At that time, it is easy to build keyboard by using push button switch. But now we can't do that. We have to use some other method to create one keyboard, because a lot of switches are there in one keyboard. Matrix keyboard is an optimal solution for handling large key requirement. The 16 key arranged for 4 cross 4 4 column 4 rows. See in this diagram here, we have here two microcontroller bar processor port. Here microcontroller bar processor port. These rows are connected to microcontroller. Here we have VCC, that is supply voltage. Supply is connected to your microcontroller only when you are pressing the switch. This is your push button switch. All here we have push button switch. If you are going to push, then there is a connection. Push to make and push to break. If you are opening that, there is no connection. If you are pushing that, there is a connection. By this manner, we have here 4 cross 4, that is 4 in the row and 4 switches in the column. That is called 4 cross 4 matrix. This is another example for input output devices in the embedded system. In the next class, we are going to discuss about communication interface. Thank you.